Okay, so this is homework 9, problem 1. And so the first part, we are to find the expected value of z of t, where we have our z of t equal to n1 of t times cos of wc times t plus theta minus n2 of t times sine of wc of t plus theta. And so we already know that n1 of t and n2 of t are WSS, and therefore, for them to be WSS, the expected value of n1 of t is going to be equal to n1, and the expected value of n2 of t is going to be equal to n of 2. And so we just put the expected value over this entire function. So it's the expected value of what we're given, n1 of t cos n minus n2 of t times sine of this product. And so this is, because of the linearity, we can split up this expected value into two components, namely this component here and this component here. And further, we can also split these individual components to two other expected values, namely the expected value of n1 of t times the expected value of cos of wc of t plus theta minus the similar thing. And so, since we know the expected value of this cos function over the bounds which were given, which is from 0 to 2 pi, this is going to be equal to 0. Because from 0 to 2 pi, the cos function has an expected value of 0. And similarly, the sine function over from 0 to 2 pi has an expected value of 0. So this becomes just n1 times 0 minus n2 times 0, which is going to give us 0. So the expected value of z of t is going to be equal to 0. In the second part, we are asked to find the autocorrelation of t1 with t2, and that's equal to the expected value of z of t1 times z of t2. And so we simply just input it into this formula. So we have z of t with t replaced by t1, and so wherever we had a t before, we just replaced with t1. And times the z of t2, so wherever we find a t, we just simply put in t2. And so we just FOIL out the inside, and so we get 4 components, and due to linearity, we can split them up into the expected value of these 4 components. And so, as you can see here, this is the first component, so it'll be the first term times this first term, which is here. Middle terms, falling out. Again, this is going to be negative because this is negative. Outer terms be the third component. And last 2 terms are going to be the last component. And so, like we did before, we can split up this first component into 2 separate expected values, namely the expected value of n1 of t times n1 of t2 times the expected value of this cos function, and the same with all these other 4 components. And we know the expected value of n1 of t1 and n1 of t2 is simply just going to be the autocorrelation of n1 of tau. I didn't write tau here, but I will in the future. So of tau times the expected value of cos of wc t1 plus theta times cos of wc t2 plus theta. And similarly, this expected value of n2 of t1 and n1 of t2 can just be rewritten as n2 times n1. Similarly, this expected value of this component here. And similar to the second term, we do the same thing for this third term. It's the expected value of n1 of t1 of n2 of t2 just simply becomes n1 times n2. And then becomes the expected times the expected value of this third component here. And lastly, just like in the first component, since we have the expected value of n2 of t1 times n2 of t2, this just becomes the autocorrelation of n2 of tau times the expected value of sine of wc of t1 plus theta times sine of wc t2 plus theta. And so we have to change these 2 trig functions into something that's more manageable. And so we're going to use some trig identities. So below here are the trig identities that we'll use to further evaluate these 4 expressions. And so we know that sine of alpha plus beta is equal to sine alpha cos beta plus cos sine alpha times sine beta. And similarly, sine of alpha minus beta is equal to sine alpha cos beta minus cos alpha sine beta. And so in order to get this first, one of the components. So let's say our last component here, which is a product of signs. In order to get a product of signs here with these two expressions, we have to add the two expressions. So then we end up with 2 sine alpha cos beta is equal to these two components cancel out. Sine of alpha plus beta plus sine of alpha minus beta divided by 2, because it's 2 sine of alpha cos beta. Similarly, in order to evaluate our middle components, which is a product of a sine and a cos, we have the cos expressions here, where cos is equal to alpha plus beta is equal to cos of alpha plus beta is equal to cos alpha cos beta minus sine alpha sine beta, and similarly cos of alpha minus beta is equal to cos alpha cos beta plus sine alpha sine beta. And so in order to evaluate these two middle terms, we want something that's going to be in terms of sine and coses. Oh, I'm sorry. In order to evaluate, this was for the middle term. In order to evaluate the first term, which is a product of coses, we have to have cos alpha cos beta. So in order to get cos alpha cos beta, like we did before, we simply just add these two expressions, and the sine alpha sine beta cancels out, and we get cos of alpha plus beta plus cos of alpha minus beta over 2, because there's 2 of these. Similarly, to get sine, we take this expression and we minus one from the other. So therefore, we would get sine of alpha sine beta minus a minus sine of alpha sine beta, which gives us 2 sine alpha sine beta. The coses cancel out, and we get cos alpha plus beta minus cos alpha minus beta over 2 for the sine expression. So we simply just plug in and evaluate. So assume we have WC of T1 plus alpha with plus theta being alpha, and WC T2 plus theta being beta, and we can substitute that in. And we notice that since we have to, for this first component, it was like, I'll give an example. So for the first component, since it was a product of cosines, we simply just end up having just the cosine of alpha plus beta plus the cosine of alpha minus beta all over 2. So this so here the cosine of alpha plus beta. So it'll be the cosine of this first component plus this first component. So here we have WC, and then just factor out WC, so it's T1 plus T2 plus 2 theta, because there's 2 thetas here. And then we have that plus cos of alpha minus beta. So we have WC T1 plus theta minus WC T2 plus theta. So we know that the thetas cancel out, and it becomes WC of T1 minus T2, which can either be written as tau. So this is the first component. And similarly, the other components are evaluated in a similar manner. And so we already know that the expected values of cos of this cos here in terms of theta is going to be equal to 0. So these 4 components here all cancel out to 0. And so we're left with just the cos of WC of tau times r of n1 of tau, or 1/2. And we also notice that the middle terms here, since this evaluates to 0, we get sine of WC of tau and negative sine of WFT of tau. So this middle term here just cancels out to 0. They just cancel each other out. And so for the last term, we have this going to be equal to 0. So we have negative cos of WC tau. So we notice we have the first component here times cos here, and the last component here times the negative cos. And so when we factor that out, we get 1/2 of r of n1 of tau minus r of n2 of tau, all times cos of WC tau. And that is our r of z of tau. And since we notice that r of z of tau, well, obviously it's just in terms of tau, therefore z of t is WSS. Because not only is the autocorrelation in terms of tau, but also, as we saw in part 1, the expected value of z of t is equal to 0. So therefore, this expression is WSS. And in the last part, we're asked to find r of z of tau for when tau is equal to 0. And so simply we just plug in 0 for wherever a tau was before, and we get r of 0 is equal to 1/2 of r of n1 of 0 minus r of n2 of 0. And that is problem 1.